This is the gyroscope lab, the hard-hitting gyroscope lab, right? Really, it's an excuse to just play with gyroscopes. The kids like to play with gyroscopes. But I have them do a series of calculations where we put this guy in here, and oh, there we go. Got it the right way, quite randomly. So this thing goes in. There's a little spot there. There's a toothed gear. Tell them not to pull it too hard, or they'll just shred the teeth off of this thing, right? But if I pull this at, say, maybe 1.5 meters per second, what's the rotational velocity of this? And they can figure that out from V equals omega R, right? And then they can find the mass of this thing, and I tell them what the cage is, and they can mass that thing, right? And then they can measure the rotor, and they can estimate the angular momentum of the gyroscope, right? Now I'm going to spin this up so that this side is spinning anti-clockwise, which means that the angular momentum vector is this way, right? And then if I put it on this stand, it's going to precess the way that we think it should using our right-hand rule, and that's all well and good. I also have them calculate the angular momentum of the Earth, right? So let's assume the Earth is a homogeneous sphere, which it's not. So 2/5 mr squared. And then I was kind of distracted by this, okay? That's going to be more distracting, right? So anyway, so then they have to figure out the angular velocity of the Earth, which is really quite small, right? Okay, and then multiply the two together. Sometimes it's kind of funny because they're only human. If they make a series of mistakes in their calculation, I've actually seen the angular momentum of this be more than the angular momentum of the Earth. Okay, guys, hang on. I'm going to turn it over. But anyway, that's kind of fun. I don't know if it's a good lab, but it was a lab. I have them do the conservation of angular momentum lab. It's a little more labby. I don't know, better.